Hmm. Folks, we are showing you a short video because of the health and safety. We cannot bring the LNG into the room, and for that you will have to understand that we have to demonstrate what LNG is about. So we are taking the help of these short videos. This is done by friends in America. They have made this video, which is a very good video about the information on an LNG, which you will understand. We cannot obviously bring the LNG here, so we are taking the help of this short video. Can you play it?
In over 64 million American homes in various industries. What I'd like to share with you today are LNG basics, the reasons why we liquefy natural gas, and also like to demonstrate the safe properties of LNG. LNG is simply natural gas in its liquid form. Natural gas is converted to LNG by simply cooling it down to minus 260 degrees Fahrenheit. This process reduces its volume by over 600 times. That's very similar to reducing the volume of a beach ball down to the volume of a ping pong ball. This allows us to transport LNG efficiently by sea. LNG is a cryogenic liquid. There are hazards of thermal burns. However, it is the warmest of all cryogens. It is also an odorless, colorless, non-toxic, and non-corrosive liquid. It is simply condensed natural gas, not compressed, and will be stored under atmospheric pressure in our tanks. As you can see, this batch is minus 260 degrees Fahrenheit. Once again, LNG is a non-corrosive liquid. As you can see, I can pour some on the table, and it simply evaporates. It doesn't eat up the table, it simply dissipates. What you'll also notice is the LNG skittering around. This is called the Leiden process. This is very similar to adding water to a hot iron skillet. Because the table is so much warmer than the boiling point of LNG, it produces an insulating layer, which actually allows it to not evaporate rapidly. Due to the Leiden process effect, because my finger is so much hotter than the boiling point of LNG, it produces an insulating layer, which protects my finger from getting burned.
We will not recommend.
Now I'm going to show you how cold minus 260 degrees Fahrenheit is. As you can see, the flour looks the same, but the cold LNG has caused embrittlement of the flour. As you can see, it breaks very easily. In the history of LNG, there's only been one incident that affected anyone on site. This occurred in 1944 in Cleveland, Ohio. This was the time before we knew the full extent of LNG properties. The problem was the tank they used was not 9% nickel steel. Today, 9% nickel steel is used in everything that touches LNG. This is a regular carbon steel pipe. Normally, it's pretty tough stuff. This is what we use to make high-pressure gasoline pipelines all across the United States. Usually, carbon steel is pretty tough stuff. As you can see, I was able to dent it, but I could not break it. But if I subject this pipe to the cold LNG, it will cause embrittlement of the pipe just like it did the rose. As you can see, this is what happened to the tank in 1944. Because of this incident, we now have the regulatory framework and the experience to keep this kind of thing from happening again. What I'd like to demonstrate now are the safe properties of LNG. A common myth or misconception is that LNG is more dangerous than other common fuels, such as propane or butane. What I'd like to demonstrate now is flame propagation speed. This is the speed that flame will travel through a flammable cloud of gas. If you think about what it sounds like when you light your propane gas grill, you get a big poof. That's because the flame propagation speed of propane is over 900 miles an hour. When you light it, you get an overpressure, which is actually a small explosion. With LNG, you get a very slow propagation speed. It's what we call a lazy flame. As you can see, you didn't get that big poof that you associate with the propane gas grill. This is what we call a lazy flame. The flame propagation speed is only 12 to 20 miles an hour. According to FERC, although a large amount of energy is stored in LNG, it cannot be released rapidly enough to cause the overpressures associated with an explosion. LNG cannot explode in an unconfined space. What you'll also notice is that the flame is not traveling all the way down to the source of the fuel. What this demonstrates is that the flame can only burn if there's the right concentration of LNG into air. And that concentration is 5 to 15% natural gas into air. So anything above this flame is entirely too lean or to burn, and anything below this tube here is entirely too rich to burn. Another thing about an LNG flame is that there is no black smoke. That's because this reaction only yields carbon dioxide and water. All the carbons are consumed. As you can see, I can stick this nice clear glass into the flame, and it remains nice and clear. Now this is a regular household candle. It's made of a paraffin wax, which is a derivative of oil byproducts. Now, if I stick the same beaker into this flame, in just seconds, you'll see unconsumed carbon build up on the beaker. Another common myth or misconception is that LNG, in the unlikely event, will release a flammable cloud of gas that will travel great distances and burn every.
Okay, folks, here I'm coming back into the loop. Now, so far we have learned few things. We have learned that it is a cryogenic liquid. It can only be carried in under certain conditions. It can be carried in the cryogenic materials, mostly 9% nickel steel, but there are aluminum which we can carry this type of cargoes. So it needs to be carried under those conditions. In addition to that, we can carry them under pressurized condition, or you have witnessed that LNG was just sitting in an open thermic glass. So our membrane tanks, which you will experience on this simulator, they are technically not designed for taking any pressure. So technically, it is a big thermos where you are loading the cargo. You can, if you want, you can open the lid and have a look at the liquid. You have seen that it is these liquids are it's a colorless liquid, and it is also odorless. Can you just see? I think there are some messages coming here. I do not want to be. So it is a colorless and odorless liquid. The flame propagation speed is just 15 to 20 miles an hour. So it means we can outrun. We can run faster than the speed of the flame. I'm not talking about Usain Bolt, it is us. So if there is fire and running behind us, we can technically go faster than that. So you have also seen the too lean and too rich concepts, which you have already learned in module 2, but I will have to tell you again because you will be dealing with that concept here. The LNG burns within the range of 5 to 15 degree centigrade, 5 to 15% of hydrocarbon by volume. So if we have any less than 5% of hydrocarbon in the tanks or in the environment, that is too lean, means there is too less hydrocarbon to burn. But once we have got more than 15% of hydrocarbon, it means that we have got too much of hydrocarbon. Hmm? So then again it is safe. To in between 5 to 15%, we will have to be very careful. That is what we call explosive envelope or the dangerous zone. So will the LNG you think will burn? The liquid will burn? What do you think, folks? Do you think LNG liquid will burn?
When?
If we light it up? If we light the LNG liquid up, it is not going to burn.
Yeah, it can't auto-ignite.
Yeah. It will, in fact, if I lit a matches and I put it inside the liquid, it is going to extinguish. The liquid will extinguish it. So in order to burn an LNG, it need to be converted to vapor. For that vapor, so can we say the LNG vapor burns? We'll have to be careful here. Yes, vapor burns, but vapor cannot on its own burn. The vapor needs to be mixed with the right amount of oxygen in order to burn. So that right amount of oxygen is in between, say, 10-11% to 21% of oxygen and the 5 to 15% of hydrocarbon. And if that is the thing, then yes, we can burn. And that is the only time when this thing is burning. Because this hydrocarbon is only a unique hydrocarbon where we have got, we have got one carbon atom joined with 4 hydrogen atoms. So because of its very low carbon contents, that is why we call it the fuel of the future. The fuel of the future means because the whole world is trying to bring it to very low level of the carbon, then of course we will have to look for the hydrocarbon which we can burn. So methane, CH4, is one of the hydrocarbon which has got lowest amount of carbon, i.e. 1. In this case, we have propane, which is, ethane, propane, butane, all these gases, but they have higher number of carbon and they contain. The more we go towards the solid hydrocarbons, we have got hydrocarbon in liquid form, we have got in liquefied gas form, we have got hydrocarbon in liquid form, for example, crude oil, petrol, benzene, etc. Then we have got hydrocarbon in solid form. The more we go on the solid form, we can see the black thing you have noticed in this short video, where we are showing that the carbon effect of this hydrocarbon. So that's why we are looking at the properties of hydrocarbon. So carbon has lowest carbon level is in methane, which is giving us the fuel for the future. It is safe with regard to the fire propagation. It is safe with regard to the condition we carry. It does not explode violently, but it can explode. I'm not saying it will never explode. In certain condition, yes, it can explode. So,
burn everything in its path. This is simply not true. What I'm going to demonstrate now is that LNG vapors actually behave more like helium versus propane or butane, which actually sink and settle to the ground. As you can see, this acts just like a helium balloon. What this demonstrates is that in the unlikely event of a release, no matter how severe, the LNG vapors will quickly rise, dissipate, and become too lean to burn. What I'm going to do now is actually make some LNG for you by simply cooling down the natural gas vapors captured into this balloon. As you can see, the balloon shrinking, that's the natural gas condensing, cooling down, and once again becoming a liquid. If you look closely, you can see a little bit of liquid on the bottom of this balloon. And now the liquid is expanding and regasifying. That's how simple this process is. There are no chemicals or high pressures associated with regasification or liquefaction. If you think about how other hydrocarbons are produced.
So folks, we have now witnessed why we are taking the port of this video is that we want to, we cannot demonstrate all these things physically here. And one picture is better than 1,000 words and one short video is better than 1,000,000 words. So now you have witnessed. This is what we are going to do on the simulator. We are going to produce gas from liquid methane, or we will turn it into gas, and we will also turn the gas into liquid through different compression systems and other systems. This is what all LNG is about. The bunkering and all those things is about this small process. You let it expand, it will turn into gas. Once it turns into gas, it takes a lot of heat to convert into gas. That heat we need to provide in the gasification process. This thing we do on board in the LNG vaporizers, where we use steam as a medium of heating, which you will experiment on the simulator. Here you can also see on the simulator that you have got an spherical LNG on the simulator, where we have got certain things, and if you will see here on this screen, these are our vaporizers. We will talk about it in detail when we will be going into the systems and working on the system. Do you have any questions so far? Rabbi, please.
To produce, this is by far the simplest and most environmentally friendly process out there. Cigarettes. These are usually a big no-no at gas stations. That's because gasoline lights around 700 degrees Fahrenheit. I could light this cigarette and get it somewhere between 700 and 800 degrees Fahrenheit. Propane lights around 870 degrees. Kerosene lights around 500 degrees. But since I know that LNG lights at over 1,000 degrees, I can actually light this cigarette, get it as hot as I possibly can, and actually put it out through the cloud of flammable gas and into the cold LNG. As you can see, this cigarette is nice, hot, cherry red. This is the area of the flammable cloud of gas. I just put it out in the cold LNG. I can assure you that's very cold. This high ignition temperature is very important for emergency crews if there ever was a fire. Just putting out a crude fire or a gasoline fire simply isn't good enough. There's usually something just hot enough, or embers, that will reignite these fires. Due to the cold nature of LNG, it is very difficult to get the surrounding areas above 1,000 degrees once this fire is out. Another myth or misconception of LNG is that in the unlikely event of a spill, there's going to be residue or a slick associated in the marine environment. First of all, an LNG spill cannot hurt the marine environment. For one thing, LNG is a lot lighter than water, so it would just float and remain on top. As you can see, the LNG is not mixing with the water, just staying on top there. Once the LNG has evaporated, the only thing that's left is a little ice that formed when the LNG evaporated. There are no slicks or residue associated with an LNG spill. To further prove the point that there's nothing left after the LNG has evaporated, I'm going to enjoy this nice, clean, cold, refreshing glass of water. This is a product that I truly believe in. Compared to other, more dangerous hydrocarbons, I feel this is our best choice for clean, safe, cheap energy.
All right, folks, there are some of the things in this video which I personally do not agree. I will personally never take a cigarette near the LNG. And this is an advice, but we do not have the choice. This is somebody else's video, so we cannot edit it. We will have to show it and acknowledge their thing. They have posted this video on YouTube as well. But because I cannot bring the LNG into the room, we do not have the choice. In order to give you the or to put the message across, this is the only way I can do it. So LNG, we will never take a flame or cigarette any way near it. We want to keep it miles away because of the risk. The risk is very high. If God forbid, if we have got this 5 to 15% of hydrocarbon by volume, and we have got a right amount of oxygen in the air, this is bound to get fire. So please just disregard that thing. But the learning process is that I will also never even drink the water. This is happening a lot, that people trying to say that LNG is a safe thing. Yes, it is a safe thing, but we are more interested in carriage of these things safely rather than using it as a drink. So, folks, that was one of the introduction of the basic LNG. The module 2 is a very comprehensive module. I understand that you have got an access to module 2, which was done by our colleagues for the project in WMU, or Maritime University. They have done a very good job in introducing those material, very informative, and I do not want to repeat those things which has already been taught by our colleagues there. So I use it as a stepping stone and move further on the. So we are coming to nearly 1:45, where we'll go for the lunch break. Do you have any questions so far with regard to LNG? Anything which is coming in your head? Because unless you understand the LNG very well, because that is what you are dealing on the simulator. If you just know it is liquefied natural gas, it is not enough. I'm going to give you some papers about the MSDS, the material safety data sheets, which you can see, and you will learn about the qualities of that, and we are also going to engage that in a small Q&A session after that. Okay, so thank you very much for this, and thank you very much to our virtual learners. We are going to have a 1 hour break, and we are going to start at 1:45 UK time. Thank you very much for being with us.
If I understand, this LNG